Hi and welcome to this 5th year higher level maths revision video. This video we're looking at worksheet 6 from 2021, which is based off trigonometry. Question 1, solving trigonometric equation. This equation is based in radians and we're going to be using the general solution. It's worth 20 marks.
Part B is slightly different because it asks us a few different things. It says the first thing, find the general solution. Actually find general solutions that satisfy this equation, and then number 2, hence solve. So we're going to use this general solution. So we didn't have to use that in the last go because they didn't specifically tell us to. So let's take a look. So we have 2 cos of 3 theta equals minus 1. So dividing across by 2 gives us cos of 3 theta is equal to minus a half. So that's the first thing that kind of went wrong for students. Then we're going to let, I can't use theta here, so I'm going to let 3 theta equal x. I kind of go between x and theta, so if the question gives me x, I use theta. If the question gives me theta, I use x. So we have the cos of x equals negative a half. So let's go to our unit circle. So we have C, A, S, and T. That is cos is positive, all is positive, tan is positive, sine is positive. So we want, well, where is cos negative? So cos is going to be positive in the first quadrant, negative in the second quadrant, negative in the third quadrant, and positive in the fourth quadrant. So we're going to just sketch this out. So we have angles here. This little angle, let's call it A, will match this one here, where A is the reference angle. Reference angle is the acute angle. In order to work out the reference angle, we simply take the positive answer to what we have. So we're going to take a half, and that will get us the reference angle. So A is equal to cos inverse of a half, and we work out our angle then in that case. Be careful, we are in this case, I know there's a degree symbol there, it shouldn't be there, that's a typo, it's a mock question. We're dealing in radians. So when we work out A, it's pi over 60. Pi over 3, which is 60 degrees. Often students really struggle with this, so what I would suggest to help is you can actually write the degrees in beside it. Sorry, so we've lost part of that. So pi over 3, and that is 60 degrees. So that is our actual reference angle. So we need to work out, well, what are the angles we are talking about. So the two angles we're talking about are in quadrants. This is quadrant 4, quadrant 1, quadrant 2, and quadrant 3. So we're talking about quadrant 2, and we're talking about quadrant 3. So for quadrant 2, we would usually do it, and you can do it in, I do it in a different color. So we would say, well, to figure out x, it would be 180 degrees minus a. So what does that mean for working in radians? Well, x is going to be 180 degrees, which is pi, minus pi over 3. So x then gives us 2 pi over 3. Over here, to get quadrant 3, x would actually be 180 degrees plus a. That means x will be pi plus pi over 3, which is 4 pi over 3. And there are two answers, but we can then get as many answers as we want. We're not trying to solve this straight away. We're actually trying to get the general solution. So in order to get the general solution, we're going to put in any number of rotations. Now, that means that what we're going to do is say x is actually equal to 2 pi over 3 plus some number of rotation. Now, usually it's 360, but we have 2 pi because we're dealing in radians, so it's 2n pi. So that's some number of rotation, where n is the number of rotations. And here is 4 pi over 3 plus 2n pi. Now, the question did not give us x, they actually gave us theta, so we're going to have 3 theta is equal to this, 2 pi over 3 plus 2n pi. And that gives us theta is 2 pi over 9 plus 2n pi over 3. Working exactly the same way here, we get 4 pi over 3 plus 2n pi. So theta is equal to 4 pi over 9 plus 2n pi over 3. And these are our general solutions. So this is the answer to the first part. These are our general solutions. Now, if they don't ask you, you can still always do that. We are then able to use these to get our answers. So how do we use these to get our answers? Well, we now have any number of rotations, so we're going to do first when n equals 0, when there are no rotations. We're then going to do n equals 1, and then n equals 2. The reason we're going to do these 3 is because, again, we're talking about 3 theta. That means there's 6 solutions. I have 2 solutions already, so I have the first 2 solutions when n is 0, 2 more solutions when n is 1, and 2 more solutions when n is 2. So I go along and I sub in n is 0, and that just gives me 2 pi over 9, and theta is 4 pi over 9. Then when we come along to do n equals 1, you can put that straight into the calculator and we get 8 pi over 9, and theta is 10 pi over 9. And for 2, theta is equal to 14 pi over 9, and theta is equal to 16 pi over 9, and we have all of our answers. So a lot going on in that question. The fact we had to first divide by 2, that was difficult. Then the fact we had to work with the general solution. Then the fact that it was in radians, all these things, but it was a mock question. So that's probably as hard as these questions can possibly get.
Question 2, we're going to look at some trigonometric function graphs, and this is worth 20 marks. For the graph below, write the function in the form y equals a plus b sine cx or y equals a plus b cos cx. So we're going to work from the graph back to the function, but the method here is just as useful if we have the function and need to draw the graph. So there's a little checklist that we use to make sure that we can very easily pull out A, B, and C, which are all transformations of a parent trigonometric function. So the first step is to always get the midline. That's going to be really the key anchor of the question. If we look at this graph, it goes up to 2 and down to -4. So halfway, that midline will be here at -1. When we have numbers that aren't as nice as 2 and -4, to get that midline, we find the average of the two numbers. The average will always give us that middle piece. So we would add 2 plus -4 and divide it by 2, and that will give us our -1. So when we have that, we now have how much or how far the function has shifted from the original midline, which would be the x-axis. So we get a equals -1. The next thing we're going to do is figure out whether this is a sine or cosine graph. So for that, we look at the start of the function. Now, when I talk about the start of the function, I mean the y-axis. They may draw the function starting before that, but remember, because a function goes on forever in both directions, technically there is no start. So when I talk about this start, I'm talking about where the angle itself is 0. So here where x is 0, so we're always looking at the y-axis. On the y-axis, this function starts away from the midline. That means it's a cos graph. The sine graph always starts at the midline, so therefore the cosine or cos graph starts away from the midline. The next thing we want to figure out is whether the graph is positive or negative. So an easy way to do this is to focus on your midline as the 0. So anything above the midline is positive and anything below the midline is negative. Focus on the first section. So this part here If that first section of the graph is below the midline, it's negative. If it was above the midline, it will be positive. So we're working with a negative graph. The next thing we want to do is get the amplitude, and the amplitude gives us b, so the coefficient of sine or cosine. In this case, cosine. The amplitude is the distance between the midline and the maximum point, or the midline and the minimum point. Okay, so that's what we have here. So there's my amplitude. It goes from -1 to 2. So my amplitude B is 3. So we're nearly there. We only have one thing left to do, and that's to work out C. There's two ways to do it, and both are equally important. It depends on the question. The easier way, and the way I would usually start, is how many rotations does this graph do in 360 degrees or in 2 pi? So starting at, again, the y-axis, it starts at the bottom. I come up to 2 pi. Now, I haven't fully rotated because I haven't gone back to where I started. I've done half a rotation. So one thing we can do is read straight off that C is a half. If you're not sure, or if that's not an easy number to read, the second option is we work out what's called the period. The period is how long it takes to rotate. So our period here, you can see it goes up, down, and we're kind of back to where we started. The period is 4 pi. So the formula for C is, if we're talking in radians, which we are, it's 2 pi divided by the period, which is 4 pi, which gives us a half. If we were dealing with degrees, the 2 pi on the top of that formula is changed to 360 degrees. So the answer for this is y equals A, which is -1. Because we have a negative graph, the b will be a negative, so it's a -3. It's a cos graph, and you can write this as a half x, or 0.5x, or x over 2. Any of those ways is absolutely perfect, 0.5x. The formula for C is very useful when C is not a particularly nice number, so when it's a decimal or a fraction. Let's do the same method again to figure out what's going on with this graph. So again, first step is our midline. It starts at, the lowest point is 0, the maximum point is at 4. I'm looking at the y values. So the midpoint is there at 2, so A is equal to 2. That midline is not just important to get our A, but also to figure out whether this is a sine or a cosine graph. Now, we want to look at where the graph starts. Here, they've given us some negative angles, but really we want to look at the y-axis. So when the angle is 0. So here's where I'm looking. That's what I consider my start. Because remember, technically the function has always gone on, because it goes on to negative infinity and it goes forward to infinity. So there is technically no start. So when we think about a start, we're really starting on the positive angle. So we're at 0. Again, this does not start at the midline, so it's a cos graph. Is this positive or negative? So because the first section, and again, when I talk about the first section, I'm again taking the start as being at the y-axis. So that start of the function is in the positive region. Remember, above the midline is plus, below the midline is negative. So there is a positive graph. Then I want to look at the amplitude. The amplitude gives me that coefficient of our sine or cosine. In terms of a transformation, it's done the stretching. So it should only go to 1 and -1, either sine or cosine. But this B, this amplitude, it has stretched it. So there's my amplitude there. We can measure from the midline to the top or the midline to the bottom, because the midline is halfway, it shouldn't matter. We get the same answer either way, and our midline is 2. The next thing, the last thing I want to get is my C. So how many rotations in, so C is how many rotations in 360 degrees, or we can use the period. Now in this graph here, if I follow it through, I can only get to pi, so I can't even see how many rotations are in 2 pi. Now, you can kind of use this and work with it a bit more logically and say, well, it rotates in pi, so then in 2 pi it must have done 2 rotations, and you simply write down c as 2. If that's not as obvious, we go back to our formula, which looks at the period, so how long it takes to do one rotation. That is pi for this question, so c is equal to 2 pi divided by pi, which gives me 2. The final answer then is y equals a, which is 2, plus b is positive here because it's a positive graph, 2 cos, and then c is 2x. And that's our final answer. When you get good at this, that checklist will become a mental checklist, so you won't have to write it down. But while you're practicing these questions, writing down that checklist and working through them, really, really useful. When you start looking at the section B style questions, so when we're working with real life examples, you will also be able to use this checklist to figure out the correct function. Question 3, solving a trigonometric equation in degrees, and this is worth 10 marks.
Example 3.4, solving equations. So find all the values of x for which sine of 3x is equal to root 3 over 2, where x is between 0 and 360 degrees, and it does say x is in degrees. So the first thing I'm going to do, and I would strongly suggest that you do, is to change that 3x. So I'm going to let 3x equals theta. And the reason I strongly suggest that students do this is because it is too easy to divide by 3 too early in the question. And if you're dividing by 3 too early, the whole question will end up wrong. So I think by doing that substitution, the division will naturally then come at the very, very end. So if I talk about sine of theta, sine is positive. So if we go to our unit circle, there's cos is positive, all is positive, sine is positive, and tan is positive. We're dealing with the scenario that sine is positive, so we're dealing in this quadrant and in this quadrant. So we need to figure out what are those angles. So if I put an angle there and also an angle here, if I do that, these little angles, let's call them A, should match. So that A is called my reference angle. It's not as important to do it here because we're already dealing with a positive. We're already dealing in quadrant 1. But I do like dealing with this reference angle. It just means as we do harder questions, it's a natural addition to the question. So we're going to do sine inverse of root 3 over 2. I would strongly advise as well to have page 13 of the log tables open and to utilize that more so than your calculator. We're dealing with degrees, so when we get this, that is 60 degrees. So in my diagram, I have a 60 degrees here and 60 degrees here. So that allows us to calculate two different angles. So the first angle that we're going to take is in quadrant 1. And in quadrant 1, it's very easy. Theta is just equal to the reference angle, so that's equal to 60 degrees. In the second quadrant, to work out theta, it's going to be 180 degrees minus my reference angle, which is A. That is 180 degrees minus 60, which gives us 120 degrees. So that gives us the base for our two angles. Well, that gives us the base for our question. We have two angles here. I'm going to just set this up. So this is quadrant 1, and we have theta equals 60 degrees. I like setting it up in columns. And then quadrant 2, and we have theta is equal to 120 degrees. We have 3x, and what that means is there's going to be 3 by 2, which is 6 solutions. So normally, if I just had an x, there would be 2 solutions. So every time I put a coefficient in front of that x, we are basically multiplying to get the number of solutions. So I need 6 different answers. So how do we progress from having this theta 60 and theta equals 120, so these two answers to getting 6 different answers. So what we're going to do is we're actually going to use some rotations. So when I rotate, I'll get back to the same angle, so the value will be the same. So the first one I'm going to do is 60 plus a rotation, which is 360, and that will give us 420. Here we have 120 degrees plus a rotation, which is 360. And when we do that, we get 480 degrees for theta. Then we can do a second rotation. So that's going to be 60 degrees plus 2 rotations. I'm going to write it like this. You'll see why in the next question. But if you don't write it like that, that's not an issue. And then we have theta is equal to 120 plus 2 times 360, which will give us a theta of a 40 degrees. And you'd say, well, actually, these answers are not between 0 and 360, like we were asked, and that is true, they're not. But also bear in mind that we weren't asked anything about theta. We were actually asked about x. So we're going back to our substitution we did here at the start, that 3x equals theta. So actually, if theta equals 60 degrees, x actually just equals 20. If theta equals 420, x equals 140. If theta equals 120, x equals 40 degrees. If theta equals 480, x equals 160 degrees. If theta equals 720, x equals 260 degrees. And if theta equals 840, x equals 280 degrees. And that gives us our 6 solutions for x between 0 and 360. So it's really important that that rotation is done before the division, which is why I would strongly suggest doing a sort of substitution. And that substitution will kind of stop you doing the division too early. So there are our answers.
Question 4 is using trigonometric formulae from page 16. So this is section B style question. It's worth 50 marks and it's really working with our triangles.
Example 3.1, using the formulae. The diagram below shows a triangular patch of ground, triangle SGH. SH is 58 meters, which is given on the diagram. GH is 30 meters, given on the diagram. And angle GHS measures 68 degrees, again given on the diagram. The circle is a helipad, and it is the incircle of triangle SGH, and it has its center at P. So we have our incircle. Find the length of SG and give your answer in meters, correct 1 decimal place. So forgetting about everything else, we have a non-right angled triangle that has 2 sides and the angle in between. So what we're going to do is we're going to use our cosine rule. So the first thing I'm going to do is I'm going to label it. So this is angle A and the opposite side is A. I'm going to call this angle B and the opposite side is B, and this angle C and the opposite side is C. So our formula, which is given on page 16 of the log tables, is up here. So we're going to have A squared equals B squared, so that's 58 squared, plus 30 squared minus 2 BC cos of 68 degrees. Now just double check before you do anything that your calculator is in degree mode. So degree mode. So if you're using a Casio, it should have a D up the top. If you are using Sharp, it will say DEG. If it doesn't, change it now. We'll put that straight into the calculator because we can. And we get A squared is 2960.369. And then to get A, we'll do the square root, and we're going to round this to 1 decimal place, which is 54.4 meters, and that is the length of SG. It's a very straightforward question. Part B, find the angle HSG. So we've just worked out that this side here is 54.4 54.4 meters. Labeling that again, we said that that was A. We said that this was B and that was C. So this time we're going to use the sine rule. We're looking for the angle HSG. So we're looking for angle C. So we have to use A. So we're going to use A over sine of A. And we're going to say that that equals C over sine of C. Now we want the angle, so actually what we can do at this point is actually use the reciprocals of this formula. That means flipping both fractions. So that's the same as saying, well, the sine of A divided by A will be equal to the sine of C divided by C. The reason we do that is because we actually want that angle C. That means it's in the top of the fraction and it makes our algebra that little bit easier. So 54.4 is equal to the sine of, I'm going to call that still angle C, all over C, which is 30. Multiplying both sides by 30, we get sine of C is equal to 30 times sine of 68 all over 54.4. To work out the angle, we're going to do sine inverse. So I will leave this to the very last minute to do any kind of actual calculation. That means I'm not wasting my time writing in decimals, which can be done incorrectly. Now some people would prefer to have decimals rather than what I have here. That's absolutely fine, but this is going to be the most accurate. We want this correct to 2 decimal places. So when we put this into the calculator, we're going to get 30.75 degrees. So that happens up here, that we have 30.75 degrees. So the next thing they ask us to do is to find the area of SGH. So we have an area formula on page 16 as well, and that's a half AB sine C. So I'm going to relabel, so I'm going to change my labels. You can do this in a different color. So I want the angle to be C. You can use anything, like we have two different angles. I prefer to work, if possible, with the things and the information that they give us, because that way it is definitely accurate. So this is going to be a half A B sine C. Now, if you worked the other way, you should get the same answer. If you are rounding it like we've done, there may be 1 decimal place out, but it's not going to impact the question. So when you put this into your calculator, you get 806.65 meters squared. So really, what we're focusing on here for this area is a half AB sine C. That means half of 2 sides and the angle in between. So we do know C, and we do know the angle A as well. So you could use those. You could work out the angle at B because all the angles add up to 180. I am literally using the information that they gave us, and now I know for sure it's 100% accurate. It does mean relabeling, but there's no problem relabeling if you have a few different colors or even using a highlighter. So part D, find the area of HSP in terms of OR, where OR is the radius. So what we're going to do is I'm going to just put in those missing lines here. So it is HSP. So this line comes down here. So that's the triangle we're working with. We don't have any angles there, but we can use our traditional formula, which is half the base, which is 58, by the perpendicular height, which is, or we know that this is perpendicular because it's the incircle. And when we have an incircle, the sides of the triangle are tangents to the circle. So that is times OR. So that works out as 29 OR meters squared. So show that the area of the whole big triangle in terms of OR can be written as 71.2 OR. So we've already just got one part of this. So what we're going to do is we're actually going to break the triangle into 3 little triangles. When you do that, each one has a perpendicular height of r. So here as well. So I'm going to use a little bit of highlighter to help on this. So we have this triangle here. So there's one that we have. We then have this triangle here. So that's the second, and the third triangle we've actually already worked out, so that's the one in or. So what we have is a half, the base, which I'm going to do the green triangle first, the base is 30 times or, plus GS, we actually worked that out earlier on. We should have that as 54.4. So this is going to be a half, this is the yellow triangle, 54.4 times or, all the perpendicular heights are or, plus a half 58 by or, so that's the triangle we've done in part I, which is just 29 or. So when you work those out, we get the first one half 30 or, that gives us 15 or, plus 27.2 or, plus 29 or, and adding those together gives us 71.2 or meters squared, which is exactly what they wanted. So it's breaking that big triangle into 3 little triangles, and that part I was kind of leading you how we could do that. So now it asks us to find the value of or. So what we've done in part C is we found the area of triangle SGH, and we said that that was 806.65 meters squared. We also then in part DII, so D part 2, worked out SGH in terms of or, and we said that that was 71.2 or meters squared. So therefore we have a little equation that says, well, 806.65 must equal 71.2 or. Therefore or must equal 806.65 divided by 71.2, and when we work that out, we work that as 11.3 meters. So part E is then a 3D trigonometry question. Notice that our triangle SGH is at the base here, so it's at the bottom, we can still see that. It tells us that ST is a vertical pole, and the angle of elevation is 14 degrees. So there's a 14 degrees that we want to put in here, and they want us to find the height of the pole and give your answer in meters correct to 1 decimal place. So I'm just pulling in the triangle that we have here. We also knew that that was 54.4 meters. We are looking for this ST, and all we know is the angle of elevation. However, the side PS here, we should be able to work out going back to our triangle at the start of the question. So looking at this line here. Now there's 2 different ways that we can approach this. Personally, I prefer to work with just right angle triangles when we can. So that's the way I'm going to focus. So we know that that or is 11.3. And I actually know what this angle is. Because that is the incircle, the way we create the incircle is by bisecting the angle. So the full angle was 30.75 degrees. And if we bisect it, we're going to divide it in 2. That will mean that this angle is 0.375. So 0.375 degrees, which basically gives us a triangle that I'm going to sketch out here. So there's 15.375 degrees. There's my right angle triangle. There's 11.3, and this is the red side that I want. Okay. So it doesn't really matter what we call it. I'm going to call this x. Think about our labeling. This is my hypotenuse and this is my opposite. Working with right angle triangles, I'm going to have the sine of angle A is opposite over hypotenuse. And that gives me a little formula that is the sine of 15.375 degrees equals 11.3 over x. Rearranging that is 11.3 divided by sine of 15.375 degrees, and that gives us x equals 42.619 meters. That is the length of PS, is 42.619 meters. So now I go back to my diagram here and I have 42.619 meters. So I have another right angle triangle that I can work with. And in this right angle triangle, I'm going to keep my color coding that I have. So you can kind of see that red line the whole way through. Love a bit of color coding. I think it keeps you very clear in the question. 619. This is what we're looking for. I'm going to call it y because we've already used x. And this is 14 degrees. Labeling, this is my opposite. This is my adjacent. That means I'm talking about tan of the angle is equal to opposite over adjacent. That is the tan of 14 degrees is equal to y over 42.619. Y is equal to 42.619 times tan of 14 degrees, and that gives us, correct to one decimal place, y equals 10.6 meters, and that is actually ST. So you could have also, and I'll give you this little note, so an alternative way to deal with this. So an alternative would be to use the sine rule. So you can actually, instead of using the right angle triangle, you can use the triangle. So from down here, you could use the triangle HPS, which is non-right angled, and then we use the sine rule. If you do it that way, you get a slightly different answer. You actually get TS is equal to 10.7, and that difference is due to rounding. So if you do it that way, you'll get PS equal to 42.73, which again is slightly different, and the difference is due to rounding. And they're absolutely fine. They'll accept both answers due to rounding. They told you to do the rounding earlier on the question, so they cannot penalise you. So the rounding is actually our answer, the main one, 10.6 is the least accurate because we've used that angle to 30.75, which was rounded. So if you do it an alternative way using the sine rule, well then you'll get a slightly different answer, and that's fine. But I would always say, like with these 3D trigonometry questions, you should be able to use your right angle triangles and use your right angle triangles. Unless you really like the sine rule and cosine rule, I would be doing the more basic formulas where you can.